All right, well, Dr. Pitcher here again, and in this lecture, we'll be looking at chirality and enantiomers. So that word is enantiomers. Just make sure you get that pronunciation. And before I start off with some definitions, I just want to mention the concept of chirality, or talk about the concept of chirality. And in fact, we can even start with some definitions. Let's go ahead and do that. So something is chiral if it has a handedness to it. And chiral objects are different than their mirror images. Different from its mirror image. An example would be my hands. I have a right hand and a left hand, and they're different. So even if I take off my wedding band, they are still different. If I tried to line them up, what we call superimposing, if I could put them actually in the same space and get the backs of the hands to line up and the palms of the hands to line up. So there's the palms. I know I've got a band-aid on there, but if I didn't, we could get the backs and the palms to line up, but the fingers would not line up. I've got my thumbs and my pinkies lined up. So if I tried to line up the fingers, well, now my palms are touching, so I'm not going to have that lining up. One is a mirror image of the other, and they are not the same. A good way to actually demonstrate that is with gloves. So your typical nitrile glove, like we have in lab, is not chiral. So here is a nitrile glove, and here is its mirror image. I know they're a little bit wrinkly, but that's okay. So one is a mirror image of the other. I will now superimpose them using my special glove superimposing technique, which is to put them both on one hand. Now if I take this off, I have one glove inside the other, and they line up. So that is superposition, or sometimes called superimposing something. Okay, we're trying to put them in the same space. Obviously, you can't really do that, but with these gloves, we kind of can. So one blue glove is a mirror image of the other blue glove, but they line up. So that's an example of an object that is not chiral or achiral. So achiral is not handed. So it is not chiral. And it is identical to its mirror image. Now, my glove example for chiral gloves would be something like these gloves here, and one is a mirror image of the other. You can see that, I've got the left-handed glove with the thumb on that side, the right-handed glove has the thumb on that side, and now if I try to, the backs are different than the fronts. Now if I try to put one glove on over the other, well, I can't really do it for one thing. Okay, I guess I just did it, except what do I have? I have the palm of one glove lined up with the back and here of the other glove. So I can't really superimpose them. They don't line up when I try to superimpose them. So that's an example. These gloves are an example of an object or objects that are chiral. Now, this chirality can be applied to molecules as well. One more term to define here actually is this one, enantiomer. So enantiomers are mirror image isomers. We'll talk about different types of isomers a little bit later on. They're pairs of compounds that are non-superimposable mirror images. So again, we can have molecules that are chiral. And let's take a look at an excuse me. Let's take a look at an example. So I'm going to draw this guy. I'm going to draw this guy here. Okay. So this is my molecule here. So I've got my carbon. So I've got a carbon. I've got my chlorine, which is green. I have a hydrogen, which is white. Coming out towards us, I have a bromine. And then going back away from us is an iodine. So here is that. So chlorine, carbon, hydrogen in the plane, bromine out front, iodine in the back. So I'm just going to place it right there. And I have made its mirror image. So what I have here is a piece of paper to be my mirror, my pretend mirror. I've got a mirror plane right here. So if you pretend this piece of paper is a mirror, one structure is a reflection of the other. Everything lines up going across. Everything does not line up, Wayne. There we go. That's better. Everything lines up going across this plane. So one is a reflection of the other. You can see my hydrogens are opposite, my iodines, my bromines, etc. So what would that look like? Well, I could draw it like this. Now I'm going to rotate this molecule 180 degrees, and I'll draw that. So my seal is up top, carbon, hydrogen is there, and this one has an iodine in front and the bromine in back. And you may notice that this structure, which is just, it's the mirror image rotated 180 degrees, this does not line up with the original structure. We can see that. If I tried to superimpose these, squish them in the same space, my carbons line up, my chlorines line up, my hydrogens line up, but I have to line up an iodine with the bromine. So, wait a minute, let me see. If I flip these around, there we go. Now I've lined up my iodine and my iodines and my bromines, but now my my chlorines and hydrogens don't line up. So these are not superimposable. These structures are enantiomers. They are a pair of enantiomers. They are non-superimposable mirror images. Okay. One more definition that I do want to introduce is what we call the asymmetric carbon. Sometimes called chiral carbon. So we'll say or chiral carbon. And that's a type of chiral center. Let me scoot this up a little bit. And chiral centers are also called stereocenters. And they are parts of a molecule, atoms in a molecule, that give rise to the chirality, that give rise to the handedness. So what is an asymmetric carbon? It is a carbon bonded, maybe I should just call it chiral carbon. Anyway, what is chiral carbon? Chiral carbons are bonded to 4 different substituents. And we'll talk a little bit more about identifying chiral carbons and distinguishing the substituents in a future video, lecture video. But for now, let's just stick with that definition. So this is a definition specific to carbon. So you can actually have more than one chiral carbon in a molecule. Now the molecules themselves may be chiral. So this guy is chiral, and this is its enantiomer. This other one is also chiral, and the first one is its enantiomer. Let me make those guys, line those up, mirror images. There we go. Each one of these molecules contains one chiral carbon. We could have molecules with multiple chiral carbons. So chiral and achiral refer to molecules, but chiral carbon refers to a specific type of carbon where we have 4 different things attached. That is just a definition. Okay, it doesn't matter if the molecule, we'll look at some examples of molecules that contain chiral carbons, but the molecules themselves are not chiral. And so containing chiral carbon is not a determination of if the molecule is carbon. I mean, you have to have at least one chiral carbon. If you have no chiral carbons, your molecule is probably going to be achiral, not chiral. If you have no chiral carbons. If you have one chiral carbon, the molecule will be chiral. If you have more than one chiral carbon, the molecule could be chiral, it could be achiral or not chiral. I tend to say not chiral instead of achiral because this, if you say it too fast, sounds like achiral carbon. No, it's achiral. Anyway, let's just stick with not chiral. All right, so that's a quick introduction, maybe not that quick, but that's an introduction to chirality and enantiomers. And in subsequent videos, we will take a look at chirality in more detail, as well as just a little preview. How do we tell these guys apart? I mean, we can look at them, but how do we identify them? They're both bromochloroiodomethane. There's no cis or trans here. So how do we identify them? We'll talk about that in a future video. All right. Well, until next time, stay safe. Bye now.